Hey there, welcome to a video discussing the last two pages of section 5.6. And my apologies for not getting this done earlier. Hopefully you're enjoying your evening, watching a little college football championship. I've actually got Alabama winning the game tonight, so we'll see what happens. So let's look at example 8. Water runs through a conical container at a rate of 2/3 cubic inches per second. The container stands points down and has a height of 6 inches, radius of 2. So if we do my snapshot, actually, I don't have to do the diagram. So if I do the snapshot, that's going to be a radius of 2 and a height of 6. That's a radius and that's a height. And this right here, just so you know, is dV over dt, which is 2/3. And it's gaining, not losing. So you're not draining water, you're putting water in, so it's a positive rate. How fast is the water level rising? So they want dH over dt. Now, since it's a cone, volume of a cone, in case you forgot, is 1/3 pi r squared h. Don't worry if you can't remember it, I'll give that to you. The issue is that we have two variables, r and h. And I don't think I want to actually plug in or try to worry about dr of dt. And actually my snapshot, I'm actually a little bit incorrect. It's actually when it's 4 inches high, the water. So the water is 4 inches high. So if you think about r and h, they are going to be proportional. The 2 and 6 is still relevant. That tells me r of h is a 1:3 ratio. So if my height is 4, then my radius is 4/3. So that's my snapshot. My radius will be 4/3. Probably should use blue for water anyway. So if r over h is 1/3, then r equals h over 3. So that's how I'm going to substitute it. 1/3 pi h over 3 squared times h. And if I clean it up, I get pi over 27 times h cubed. Now I take my derivative with respect to time. Times dH over dt. And my job now is to solve for dH over dt. dV over dt we know is 2/3 again. So 2/3, and that cancels, that's pi over 9. And h at this moment is 4 times dH over dt. If you move things around, uh, 2/3 equals pi over 9 times 16 times dH over dt. 2/3 times 9/16 times 1 over pi equals dH over dt. And that becomes 8. So I'm getting 3 over 8 pi. And that's going to be inches per second. That's how the water level changes when the radius is actually, when the height or when the water depth is 4 inches high. And if you were to look at the filled out notes, let me pull it up. Yep, that's exactly what we have there. So you can see it's all kind of worked out. You have your volume. In this case, Mrs. Blanford did these notes. She decided to keep everything in terms of R. I'm not sure why she did that. think much easier if you isolate R in terms of H, and then solve for d through dt. But I don't know. I guess that's fine too, because H is 3 times R anyway, given the ratio between R and H. Then the last one, example 9. So we got Mr. Bell. He's walking away from a street light, which is 15 feet above the ground. He's walking at a rate of 5 feet per second. So we want to kind of draw this. Actually, it should be touching his head, his bald head. Don't tell me I said that. Anyway, the light might reflect. No, okay, I'll stop making jokes about Mr. Bell. So we got 2 triangles here. Now, clearly, well, I don't say clearly, but I'm going to call this X. I'm going to call this Y. X is a distance that Mr. Bell is from the street light or lamppost, and Y is going to be the shadow, just so you know. So the first part is the what rate is the length of the shadow changing. So Y is the shadow length. So what rate is the length of the shadow changing when he's 20 feet from the base of the light? So we'll do a snapshot diagram. This will be 20 plus Y, and that's 15, of course. Excuse me. So he's walking at a rate of 5 feet per second. So this is my general diagram. That's my snapshot. So one way we can kind of think about this is using, and he's 6 feet tall. We know this also. So I should have labeled that as well. So you can think of it as like similar triangles. We have 2 triangles. You have 6 and Y. You have 15 and X plus Y. So in this case, we could say X plus Y over 15 equals Y over 6. If you cross multiply, 6x plus 6y equals 15y, 9y equals 6x. So coming with the equations can be a little tricky, but that's my equation there. Then if I take the derivative of that with respect to time, I get 6 dx dt and 9 dy dt. dy dt is what I want. I want how the shadow's changing. Dx or dt is this right here, the rate at which he walks, because that's how that changing, that distance between Mr. Bell and the light post is changing by 5 feet per second. So I do 6 times 5 equals 9 times dy over dt. dy over dt is going to be 30 out of 9, or 10/3. That's 10/3 feet per second. And if I show the filled out solutions, yeah, that's what we get for part A. Part B is a little tricky though. Not my favorite problem. For part B, you want to know the tip of the shadow. So it's actually a different thing. So I'm going to call this whole thing here Z. That's how the tip of the shadow is changing, because the shadow is also determined by how far he is from the light post as well. The tip of the shadow, sorry, not the shadow length. So we're going to call that whole thing Z there. Again, that's 15, and that's 6, and that's 20. And we'll call that 20 minus Z. So then what you do is you're going to say, look at 2 triangles, 15 and Z, and 6 and 20 minus z. And they're similar triangles. Similar because they both share this angle here, and the sides are proportional, and also at right angles. You have, all the angles are the same. So you can say z over 15 equals 20 minus z over 6. Cross multiply, 6z equals 300 minus 15z. Oh, oops, sorry. I'm gonna say z minus 20, yikes. My apologies. That should be z minus 20. Yeah, I knew something seemed a little off there. 15z minus 300. Okay, that I feel a little better about that. So 300 equals 9z. So z would be 300 over 9, which actually reduces 100 over 3, I think. I'm not sure if I did that correctly, because look at the answer key doesn't quite agree. So I wonder what I did wrong. Give me a sec here, because I told you it's not my favorite problem to do. 6 or 15. That's interesting, because I had the same thing. I guess we don't really know if it's 20. I mean, that's actually, you know what? I mean, now I know the mistake I made. We can't substitute too soon. I told you guys not to do that. That's my fault. So let's call this like x and y again. And that's z. Okay. That's 6, and that's 15. So y I know is going to be z minus x. So let's do this again. Sorry, we'll do a do-over. So y over 6 equals z over 15. So 15y equals 6z. Or 15 times dy over dt equals 6 times dz over dt. Now, we solved for dy over dt earlier. We got that as 10/3. So 15 times 10/3 equals 6 times dz over dt. That's 150 out of 18. Those are each divisible by 3. So 50 over 6, or 25 over 3. That's a lot better now. So dz over dt is 25 out of 3. And you're looking at the z because that's how the whole tip of the shadow is going to be changing by the distance that Mr. Bell walks, as well as the shadow length. That's how the tip of the shadow moves. So, and that's inches per or feet per second. Okay, my bad that I botched that one, because I was not supposed to plug in that 20, because we need kind of a general way of doing it first. So, okay, so that's the end of the video, and we'll talk more about this in class on Wednesday.